So, in summary, if the discriminant, or if b squared minus 4ac is less than 0, there are no solutions. So that means the graph of it would look something like a vertex here and it opening up. It never touches that x-axis, or a vertex down here and it opening down. So if the vertex is above the x-axis and opens up, you don't have any solutions. And if the vertex is below the x-axis and opens down, then there are no solutions because it never touches the x-axis. If b squared minus 4ac, or the discriminant, equals 0, then there is only one solution. So that means if I were to graph that quadratic, it would start at the x-axis and only touch once at the vertex. If b squared minus 4ac is greater than 0, we have two solutions. So if we would graph that quadratic, it would look something like this, or something like this. Okay, it would always touch at two places. Now there's one kind of extra little tidbit, and that's if b squared minus 4ac is greater than 0 and a perfect square, then the quadratic could have been factored. So for example, if I said x squared minus x minus 12 equals 0, okay, so that's when we say, if we were to write the function of it, so equals y, but we want to find out where the x intercepts are, so y equals 0. So to solve this, I would say x minus 4, x plus 3, because negative 4 times 3 is negative 12, negative 4 plus 3 is negative 1. So that means that we have x equaling 4 and negative 3. So let's use the discriminant to see if there had been a perfect square. So I would say a equals 1, b equals negative 1, and c equals negative 12. So b squared minus 4ac equals negative 1 squared minus 4 times a, which is 1, times c, which is negative 12. So 1 minus, just kidding, negative times a negative is a positive, 48, because 4 times 12 is 48, is 49. So yes, indeed, we get a discriminant that is bigger than 0 and is a perfect square. So that means we could have solved it by factoring, and look at that. We did solve it by factoring.